Okay, hi everyone. So we are having a busy afternoon of live stream meetings. This is another meeting related to Wolfram language design. This is part of our language completeness and consistency series, talking about a variety of topics that have come up there. We will be in about an hour doing a meeting about black holes and physics, completely different subject. This is why I have an interesting life. Very diverse collection of issues. So let's jump into this. The at equals operator. Okay, remind me what the at equals operator is supposed to do.
It's supposed to be, so you do x at equal map of f, and it evaluates basically to x equals map of f of x.
Okay, so in other words, what we're saying is this running in any versions?
No.
Okay.
Because we haven't picked a name for the symbol, and so we can't create a full form if we don't have a name.
Fair enough. Okay, so fundamentally it's x at equals f, and that is equivalent to x equals f of x.
Yep.
Yeah, that's kind of nice. How certain are you? I mean, if we put this into 12.2, it would be interesting to see if people find that they use it.
Right. This was actually an external suggestion. I forget from who, but okay. Maybe Sander.
Okay.
I mean, I wasn't involved in the curation of this suggestion, but I have to say that there would definitely have been times I would have used it.
Right, because
it seems very sensible to me.
Right, because especially if you know f is not just f, but some composition of operator forms, then.
All right, let's talk.
Well, actually, in my case, I might very well have used it just in the single case because it helps to kind of prevent the levels of nesting that make it unreadable. If you're applying a series of transformations, you can put them all nested in square brackets and it becomes very difficult to read, or you can have a series of lines that, x at equals first transformation, x at equals second transformation.
Mm-hmm.
Oh, I see what you're saying. I see. That's nice. Right. I mean, so in other words, you're saying x at equals f, x at equals g. That's really pretty nice, actually.
Yeah.
Good idea. Okay.
Yeah,
so
I think it really make a difference for readability in certain kinds of code.
Okay, it is indeed Sander probably who was the originator of this. Good. Okay, so let's talk precedence here. So clearly ampersand, it should be lower precedence than ampersand. We agree? So in other words, we should be able to type x at equals 1 plus hash ampersand.
Yeah.
That's important.
So now, interestingly, if you look at plus equal, minus equal, star equal, slash equal, those are just slightly higher than ampersand.
Right. Okay, that's one of the things I put in my discussion.
Can we look at the precedence table? Where is the precedence table?
You can just search the help for
operator input forms.
Yeah.
Okay. All right. Where's our zone?
You want to look close to the bottom of that first table. You're still in the first table. It's a long table, but
okay. So
yeah, there you go. There you go.
Hold on. First question is, so let's talk about some above and below ones. Okay. Mm-hmm. Sandra is pointing out a precedence stuff in the Redmine issues tracker. Somebody bring that up, please. Gosh, I don't even know my login to this thing, I'm afraid. Great. could somebody please bring up the relevant entry?
I'm looking at it.
635.
I'm trying to see.
Issue 635.
Yeah. I'm trying to see what to glean from here.
Okay, so let's talk about it. Should be higher than, should be lower than. Okay. Okay, so it should be lower than ampersand for sure. It should be higher than equals sign, right? Because you've got to be able to say x equals whatever, right?
Yeah.
Mm-hmm.
Okay, so let's see where that brackets us here. Okay, so there's ampersand, lower than ampersand. Okay, so there's / here. Are we already toast? Is equals higher than?
No, equals is fourth from the bottom. Or sorry, set. I'm sorry, set is fourth from the bottom.
Okay, so basically we're living in this zone here. If we're lower than ampersand and higher than equals, then we live in this zone here. So the only things that we can, / is an important one. Okay, so let's talk about that case. So we've got x at equals f // So I think it'd be nice to be lower precedence than //. Do you agree? I think it really would be nice to be lower precedence than //.
Lower precedence, so that means that's
that's really a question of, does the assignment, because this could be either could return. I mean, either way, this is going to return g of f of x. It's always going to return that. The question is, what did it assign? Did it assign f of x, or did it assign g of f of x?
No, that's not true, right? If it's lower, then it would be f of g applied to x as opposed to.
I mean g of f.
Yes, sorry, g of f applied to x as opposed to g of f of x.
Oh, well, that's crazy.
It depends what f and g are, perhaps.
No, it's crazy because I mean, if it's / there, composition. No, I'm just simply wrong. I mean, it has to be. This has to parenthesize like this. It couldn't make any sense otherwise. You're just going to have a bug every time.
Right.
Yeah, I tend to agree with that. Which leaves colon.
Perhaps you were thinking of right composition.
I was, yes, but I mean, so. Okay, so where is right composition in the precedence table?
It's way above.
Yeah.
I don't remember.
Oh, okay, so fine. So it's way above, so that's no problem.
Right.
Right.
Okay. So, okay, so what's left is colon, right? And there's therefore, which I think is a.
Right, and colon is kind of ridiculous, right? I mean, it's the thing that just formats as a colon. That's not an actual colon on the keyboard.
What is it? I don't understand what that is. And vertical separator is the same stuff. Well, then I would think this should be lower precedence than those. So I think this precedence is right above the precedence of equals. Do you agree?
Right. Yeah.
I'm okay with that.
Yep.
Okay. All right. That's okay. Now let's talk about names. The full name of this. By the way, I would like to comment.
And I should say, unlike Itai, I don't have to wait for a name, so I can.
Yes.
Yeah. I if you want, I can just Itai. I can just go ahead and implement this probably today.
As an ASCII operator.
As an ASCII operator, yes.
Right. You'd need the name for the Unicode operator. which I presume we'd also want.
Do we want a Unicode operator for this?
I'm not sure it's necessary.
Why
I mean,
necessary?
I'm happy to discuss it if you want it, but it doesn't seem necessary to me.
Okay.
Okay, let's talk about the naming of operator forms, because I have always been upset, or recently been upset, that at does not have a name. In other words, I've often wanted to, you know, why do I need this? I want to, gosh, what is the use case? I need it to have a name, basically. And it's like, you know, it's sort of apply one.
Well, it's exactly right.
Okay, Sander is pointing out the idea that a single argument version that converts any function like plus into add to into an apply and place function would be neat. Okay, let's understand what that means. So let's say this thing is called well, I mean, I would have thought this was by the way, it doesn't matter that the name is short for this thing. Really, really doesn't matter. It might matter more if there's a cool operator form. But I mean, it's a terrible name, but you know, set construct is what it really is. Or no, actually, well, construct to or something, isn't it? Or isn't the F? I mean, something where we say construct fx. That's the name for the applying a function, right?
Right. I mean, I guess compose does that too. Although is compose the deprecated one? I can't remember.
Yeah, compose is deprecated.
Right. I mean, right. Unlike construct, this isn't var arg, right? And construct is var arg, right? That's the one that takes f,
Yes.
x, and y and creates f of x, y.
Then that should be construct equal.
What do you mean equal? Because it's not equal. Construct. It's not
No,
equal.
you mean at equal. We're talking about that.
Yeah, we're talking about that's the whole topic.
Yeah, so it should have equal in the name because plus equal and others.
What are you talking about?
No, plus equal is add to. There's no.
Oh, okay. Yeah.
We're using this to construct.
Mhm.
To me, it is being applied to something. But I'm trying to understand Sander's suggestion about a single argument version that turns it into add to. So let me just understand that. So add to takes an x and it takes a dx, so to speak.
Mm-hmm.
Okay. So the question then is there a thing that would take this function, okay, so a headdress effectively, that will turn plus into add to, right? So this is a toing headdress. So here's what it would be. It would be the this is a terrible name, but something like operator 2 of f of x comma dx, and that would become x equals, let's call this y.
Here immediately we find the problem of hold first.
Yes, and we find another problem as well, which is that add to is expecting two arguments here. Right, this is in fact, I'm confused here. This is, let's see, x equals it, but that's not the correct add to form. The correct add to form is instead x equals f of x.
Fx equal, yeah.
Right.
Mm-hmm.
Oh, but that's, I see. If you omitted the x, that would be, okay, so fine, I understand. So that also suggests a currying mechanism for this thing here. Because you can imagine that if I say x equals f of x, look. If that was construct2 with f, x, y, z, okay? That could be x equals f of x, y, z. Could it not be? Where basically the y and z are constants. See what I'm saying?
Mm-hmm.
But the order is a bit strange. I would
Yes.
expect AX to be the first one.
F and X are both special.
Right. But I mean, it would be lovely if the operator form of this, the operator form of this construct2 thing, if it was possible to do it, if we could say construct2 of f, okay, we understand what that operator form would be, I think.
Mm-hmm.
And that operator form would, but now I don't even know if the operator
but it
form
would
can
be
work with hold
useless.
first. Yes, because it can't do hold first.
Could it return a pure function?
Ian, you're very soft, so I can't actually hear what
Could
you're
it return
saying.
a pure function?
As a way to deal with the holding.
Right.
Probably could. Let's see, Sandra is making an interesting suggestion of a set2 function where, let's see, wait a minute, SetBy rather. Yeah, SWSH is saying that they're not a fan of mutable functions, nor am I. But mutability is something we humans seem to understand well, even though, at least, yeah. Okay, but let's look at SetBy. So
Is this an alternate name for our construct2, or is this a new function?
I think this is related. I mean, so the suggestion being made is that SetBy of square root
Mm-hmm.
could then be applied to wait a minute. Oh, I see. So if there's an x there, this would become x equals square root of x. But why isn't that the same as what we just did?
Yeah.
Isn't this just what we've just got? Isn't this the x add equals square root?
Yes.
Yeah.
What am I missing? Seems right, but
And it doesn't actually work.
I see. The proposal is that it'd be possible to get a function where you could say square root 2 equals SetBy square root.
Mm-hmm.
But the issue there is that the subvalue can't reach in and prevent evaluation of the x. Right?
Right.
How fundamental, just for my understanding of, I mean, it's got 30-something years of history, but how fundamental is the inability of a subvalue to affect its arguments? Is that deeply fundamental, or is that something that we could imagine changing at some point? In other words, could there be a I mean, it would be basically hold, instead of hold first, hold rest, it would be hold subvalue. That would then be the head of the head of the head determines what is being evaluated.
Rob, any insight into that? I mean, I'm not sure I'm not sure we have the bits for extra attributes, but even if we did, I'm not sure how hard this would be.
Can
Yeah,
Rob
bits
comment
are-
on that?
Bits are pretty scarce.
Well, forget that issue, because that's another issue that we have to address separately. But I'm asking the question: is it worth considering the possibility of a hold subvalue? And if we did that, what consequences would it have? Because, for example, in this case, then, what's being proposed as SetBy could have an operator form, and the subvalue could work. Somebody's got a lot of background noise there.
Right. So I honestly don't know whether it would even be possible.
Well, maybe we can investigate that. But I mean, okay, so the proposal here, so Sanders' proposed name here of SetBy is interesting and not an obviously bad name.
Right. Yeah, and certainly the two, argument form.
It's fine. I mean,
Is
set
it-
by x comma. So the form would be, it would be x comma f.
Yep, and it would be hold first, and that seems like a fine suggestion.
Right, and one could even, potentially have, although this may be an unnecessary, confusing luxury, would be to have additional arguments there, yz, which would be essentially put into where the answer would then be x equals f of xyz. I don't know whether anybody cares about that. I think it becomes more interesting in some operator forms. I'm not sure that that's worth doing. You could perfectly well just have the f be a hash thing there. All right, let's just think about SetBy for a second. Is that consistent with our other use of by and other functions?
I think so, right? Because, for example, if you have sort by, right, it applies the function and then uses that to sort. So here it's applying the function and then it's using that to set.
Whoever's making a lot of background noise, maybe it's Rob. Could you mute, please?
I mean, the rest of the by functions I sort of think of as being things that are iterating over a list.
Yeah, I would expect SetBy to be x comma y comma f, and it first applies f to the y.
Well, I mean, the more, set with would be a more English language thing, but unfortunately with has so many other connotations for us. Set after, not very good.
I'm missing the two, because everything we have, which is L value, has this two.
I mean,
Yeah.
but the two is sort of redundant with set.
Right.
No, because set always has the left-hand side and the right-hand side.
Right, but the two always implies the left-hand side.
Right. I mean, the two add to. The two is the thing that's indicating the mutability part, the assignment part of it. And the add is indicating the operation.
Right. And then set is the thing that's indicating the mutability, right? That
Right.
the left hand, that the first argument is going to be changed.
I mean, absent an operator form of this, which would be nice to have, but absent that operator form, and by the way, I mean, in principle, although it's pretty complicated, I mean, function, if it returned a pure function, function does have a third argument with attributes, right? So you could say function of f of hash, what would you say? You'd say function of, how does this even work? X equals f of x, hold first. Doesn't that work?
Yes.
So in principle, as I think Ian was indicating, SetBy of f could in principle return that pure function, and it would then work.
Well, perhaps by that time it has also evaluated the other bracket.
Which other bracket?
If you say f or g goes to this function object, and then g of 1 plus 1, I suspect it will have evaluated the 1 plus 1 before using the function.
No,
Yes,
but heads evaluate before arguments.
No, but that's not the point. The point is here, this thing here, if I have a variable xxx equals 7, okay, and now I apply this thing to xxx, it will give me f of 7, and xxx will be f of 7, and we're good.
Yes, but what I don't know, if you call g equals this function and then applies g of xxx.
I see what you're saying. Let's take a look at that. I'm not sure that's going to work. Yeah, g of that, and then say ggg of xxx.
Right, because again, heads evaluate before arguments.
So you're saying that worked?
Yes.
So it is feasible by the slight hack of having the operator form actually evaluate to a pure function. We could make this work.
Right.
Okay, so I think we should look at the operator form seriously then. So that argues, okay, so I mean, Sandra is commenting that all of our things, times by, add to, subtract from, they're all horrifyingly different. Gersik is saying that they like set 2. I think that's a little obscure. I think set with, set by, set after.
Set using. Right. I mean, I guess set by is like consistent with, well, no, it's the opposite sense, right? We have divide by is one of our, so in that sense, it's sort of reversing the.
Yeah, it's hopelessly reversing it. Well, okay, here's a version that that's kind of crazy because all the other ones are times. Oh, why does it always come down to names? Okay, we've got several candidate names here. We've got set2. Hold on, I just need to save this in the appropriate place. Does anybody know? Well, I'm going to save this just under functional programming, even though this is specifically not a piece of functional programming, sadly.
So I'm wondering whether if we look at a larger class of functions, if it helps with the naming. Right, like, so suppose we also added map2, which is basically whatever the thing is that we haven't named, with the right-hand side being...
You're saying that this would be x equals f slash at x.
Correct.
Right, well, I think then we're back to construct to, or possibly apply to.
Yeah, my favorite
Except
is
it
actually...
apply.
It is not applied, but we have applied sites, image apply, various things that are not following apply.
Sorry, say that again. I see. You're saying that apply has been already abused.
Yes.
Apply is already a general concept, not a specific one.
Right. So we have apply sides, which applies f to all sides of an equation.
Where by apply we just mean saying f of x, not f at x.
Correct.
Image apply.
Well,
then.
I mean, so then apply to is the obvious name. And the operator form apply to f is fine. I mean, but this is, most of the time people will just type at equals and it will be called at equals. And the knowledge that at equals happens to be applied to is, look, apply to is the obvious name.
Right. Unless we want to call it at equals.
No, we haven't done that. That is a self-referential confusion, so to speak. Just imagine all the things that were, that does not even give people a hope.
Yes.
If map is turned into, is name / at. All right, I think we got it. Apply to, I think we should look at an operator form that evaluates to this pure function with a hold first. And I think we've got this.
So out of curiosity, in like add to, in the full form, which order are the arguments?
It's x comma dx.
Okay.
So the argument, so what you're saying is apply to goes x comma f, right?
Right, but what I was wondering is whether you can then say x comma f comma 1 and get the triple at version, through a full form, even if there's not an operator for it.
So what are you proposing there? That's apply. You're saying you want to have a level spec.
I'm throwing it out there as a possibility.
I think the level spec has many different possible things. I mean, you might want a map, you might want an apply, you might want to apply at level 1. I mean, I guess you can get all of those with level specs. No, you can't. One of them is going to, I mean, the map versus the apply is different.
Exactly.
So what Brett is saying is that if we go this route, we cannot have the 2 version of the true apply.
Wait,
we haven't
is that
missed
what I'm
it
saying?
in 30 years. Yeah, it is what it's an implication of what you're saying. That saying x equals f at x.
Right.
But you're never going to want to do that because think about the syntax. This is never going to work because the only way that would work is if x is a list. Oh, I guess it could. Yeah, I'm sorry. It could work.
Yeah, but it's weird.
We haven't needed it in 30 years. I think we probably are not going to need this.
Right. I mean, the triple at version could work. We might be interesting, but
let's go ahead and implement apply to and get it all working and play with it. Okay.
Okay. Yeah, triple at was what I had in mind.
Okay, so this is sort of, if you want,
horrifying business.
Right.
Well,
so
the fact that it doesn't round trip is totally horrifying. Look, the point is we didn't use this for a round. So this is purely decorative. This plus equals is a purely decorative thing.
Right. Well, plus minus and minus plus.
I'm sorry, plus minus minus plus, yes. Are they mixable?
Well, in this, I mean, not flatly, right? But you could.
I see. So do you propose that this be flattenable like inequalities?
Or like plus?
No, but plus and minus, right?
You mean, no, I'm not proposing that, although I suppose we could. I'm proposing that plus minus itself be flattenable. And so we...
Well, I don't know what these are used for, because these don't have they don't currently have an evaluation meaning.
Right. Well, they're used for formatting, and people do use them.
I would find that dangerous because we have a minus there. If we make it flatten, it's like making minus flatten.
But minus is flat, as I just showed above.
Yeah, I mean, minus and plus flatten to one another.
Okay, look. First point is, we're not really using plus minus.
Yeah, I mean, actually, what isn't shown above, but is true, at least in the front end, I assume is true in the kernel as well, is that A plus B minus C is also flat.
Yes. In a very weird way.
Right.
And the front end considers it flat. There is no associativity there as far as front end is concerned. That's a flat row box.
Right. So what would be involved in making plus minus and minus plus fully
mutually flat?
So I didn't. Itai, I didn't realize this was your proposal. I thought that you were proposing making it flat with plus and minus.
Well, that's a whole different thing. So that's mutually flattenable with plus, minus, plus minus, and minus plus.
But look, I'm confused here. I think this minus might mean subtract.
Minus never means subtract.
But in plus minus, when you have plus minus, you might be meaning I have either A plus B or subtract A comma B.
Okay.
So... hold on. Let me just understand something. I mean, we have never implemented even like the quadratic formula with plus minus, right? Plus minus is purely decorative right now.
Mm-hmm.
We did consider the possibility of actually having, I mean, we could perfectly well have an algebra of plus minuses. We just haven't done it. Do we want to do that? I mean, that was on the table a couple of years ago to do that.
I don't think we want to do that. I just think, I just think we should make, these things round trip properly because there are bug reports about this.
Okay, I understand. The round tripping is reasonable, but I'm asking the question, which I think is a separate question, and nobody in this meeting is probably equipped to answer it, of whether we make plus minus we could perfectly well have an algebra of plus minuses, which would be what?
I think that's what a round is for.
No, but not for the quadratic formula.
Right.
That's the whole point. That's what a round is, a plus minus in the sense of
I see
a distribution. That's a plus minus in the sense of multiple choices.
I see.
And I think plus minus is like an interval. It's like something where it's just it's a discrete, it defines a discrete set. And if you're doing that, A plus minus B plus minus C, if you were to resolve that, how many elements does it have? Does it have 4 elements? Does it have, I think there's an argument that it should have 4 elements, for all possible signs plus minus threading through there.
Mm-hmm.
Well, but these things are, for example, you may want to have 2 equations, one with all the signs on the top and another with all the signs on the bottom, and not all the powers of 2.
Right, but if you were to nest the plus minuses, then, this version here, right, is clearly the case of 4 things. Is that not right?
Yes, but what I mean is that if you flatten it, then you might mean that you have 2, one with the top signs, one with the bottom signs.
So the argument there is that this is in fact not a flat operator.
Right. That's what I'm saying.
Which means
hold on. No, the fact that you can parenthesize and Well, okay, so there's flat in the sense of the attribute flat, but there's also flat parsing, right? So if if plus minus of ABC is to make any sense, then A plus minus B plus minus C must parse to plus minus of ABC, which it doesn't.
Okay, I understand that issue. But then what do you think that means if we were to have plus minus resolve, right, of this, whatever, if we would have a function plus minus resolve.
Well, if we want to give it, if we're saying that that's distinct, then that's the one where they're all plus or all minus.
Okay, so you're saying this turns into, A plus B plus C, A minus B minus C.
Right.
Whereas this thing here, which is right now the parse form of this, would be the thing which I think correctly would turn into, whatever it is, all the four cases. ...
Yeah, I agree with that.
So, okay, so what does that mean about parsing? That means that the flattened form of the flattened parse should turn into the var args plus minus.
Yep.
And the var args plus minus should be, if we represent it algebraically, should be the upper signs and the lower signs, but not mixing.
Right.
Which I think is reasonable. Now, I think it's a separate discussion, and I think we have coming up a discussion about elementary math and our support for additional elementary math things. We might bring up this plus minus in that. Devin, if you can, not sure who is PMing that. That's something in the Roger Empire.
Sure. Yeah, I can check.
Okay. All right. So what are the other questions here? We're just saying this will flat parse to the var args form.
Right. And then I guess the other question is, should we allow it to auto flatten with plus and
auto flatten with plus. I will be super careful until we understand the algebra.
Right.
Because I don't even know what the minus of this whole thing. I don't know what that means. It'll depend on which of these sets or the upper and lower rails there are, something like that. Yeah,
so it's hardly impossible, but I'll just point out that it will be a bit tricky to implement because we have 4 things that have the same precedence. 2 of them will merge with one another, and the other 2 will remain separate, but they'll all flatten in some way.
I think this implementation should be, I think we should not go to a lot of effort here until we understand more about this algebra, because I think we may yet have some issues there. By the way, we have a couple of comments on the live stream I wanted to respond to. So Sandra's pointing out that x at equals apply of f would correctly do the application version of at equals. Although it wouldn't do the apply one version, although if we named triple at apply one, it would do that. What do people think about naming triple at? Because I think that's a good case, right? So let's look at that case. So this case, x equals x at equal apply f does the obvious thing, right? But then the question is, what is the version x at equal apply f to hash comma 1, which is the form for f triple, or I would write it a different way. F at equals f triple at hash ampersand, right? Which will take f and put it into the list elements that are in x. If I'm not mistaken. Am I confused here? I'm now losing it. This will take it. So if x is equal to ABC,
yeah,
this will be an f at A, F at B, F at C. Now, notice that X at equals map of F will just do the right thing. That'll work perfectly. So the only one that's kind of awkward is this triple at one. Again, feedback on apply one.
I was looking at which other functions end in one. They are all
Very
super
few.
mathematical.
Yeah,
We have a
very
few, but very super mathematical. I mean, we have
Yeah, I know that, which is why I was also concerned about that. I mean, it could be
apply top or apply.
Yeah, apply top is a possibility.
Apply first.
We don't usually. What's that?
Apply first, maybe.
First
No,
seems
it's
like
not
imposition.
first. Completely wrong.
Right.
So again, F triple at, let's say, A, B, C, D. Okay, does that. Okay, so how would we describe that?
Apply
Maybe
inner.
Apply first level.
Apply each.
That's interesting.
Yeah.
That's interesting. We need to wrap soon here. Apply each is interesting. I kind of like that.
Yeah, that's a good name. Yeah. Mhm.
Yeah, it's good.
Will it just evaluate directly to apply of blah, blah, blah?
Well, I think it would do the evaluation. It's not going to turn into apply blah base one and so on.
And this is basically so we can get an operator form, right?
Yes. Because apply each of X of F would be F triple at.
Well, I'm a bit worried here, right? Because if this, right, I mean, I think you're suggesting that we actually change what triple at parses to, and that has.
Oh, I'm less concerned about that. I'm more concerned about providing an operator form. If there's an issue with what it parses to right now, I wouldn't worry about it too much.
Right, because right now it parses directly to apply, right? And which if it just goes ahead and evaluates right away is not a problem. But if somebody is, actually looking at the result of, is doing held evaluation and checking heads, that can break things.
Okay, we've got a few other comments on the live stream, and then we have to wrap this particular meeting. So Sander is asking rather amusingly, if we have at equals, do we also have equals at? I think no. That is a thing which is the the analog of pre-increment.
Oh God, no.
Jose on live stream is asking, an operator form of apply F at level N. Something like the map at function. Oh, I see. Of apply. It's asking for an operator form of apply F hash N.
Can't you do that with map at and just giving it a 0?
Yes, you can. It's just rather ugly.
Right. I mean, if apply each is really just for the operator form, then it could be apply each F comma level spec.
You mean if it's a pure operator form, if it doesn't have, if apply each is not, doesn't have, you're suggesting that apply each F, that's going to get really confusing, level there, with this being a pure, we haven't really done that, a pure subvalue thing.
Mm-hmm. Right.
I think we need to separately do it. Yeah, go ahead.
We have echo function, for example.
And it ends with the word function.
Yes, but I mean something that is only a.
I think we should let's look at this. Let's bring it back to a separate meeting. I don't think we should conclude this here. The various suggestions here about x triple at equals, which is exotic. Let's remember those, but let's get at equals implemented, and then let's kind of see how that feels first. All right, I have to switch to a completely different topic. Good. All right. Anything else right now? I think we're out of time here.
Okay.
Okay. Thanks all. Okay, so people paying attention to live streams, we are about to switch to a live stream about black holes. And I just need to reset for a moment, and then I'll be right there. Okay, so thanks all. See you all soon. And Jose, could you join us? Did you get the information?
Okay, I will.
Okay, great. Thanks. Okay.